Okay, so to talk about symmetry, we're talking about symmetry of functions and their graphs. So let's start off with something simple, and I'm going to start off with something that is an even function. So we're going to start off there, and we're going to do visual first. So what does it mean for a function to be even? Okay, it's really one thing and one thing only that makes a function even, and that is, all it is it's something that once you've drawn it, if you can fold it in half across the y-axis. So we've got two things going on here, right? You have your x-axis and you have your y-axis. If you look at that graph right here, and this graph, as you guys know, this is just a parabola. So let's call this f of x equals x squared, nice and simple. Okay. You look at this function and you can fold it in half right across the y-axis, which means you see the y-axis, that's the fold in your piece of paper, and it's the same picture. It's symmetric. It's like a butterfly. That's what an even function is. So that's exactly what it means for something to be even. Another way that this can be written, though, is this could be called symmetric about the y-axis, okay? And even another way, let's do the mathematical version of it, the same thing. These all mean the same thing, by the way. Another way is if you were to plug in a negative value into your function, you would get the exact same thing as if you plugged in a positive value. Think about it this way. Here is my positive 2, I got 4. Here is my negative 2, I still got 4. So the idea is it didn't matter if I plugged in the positive or the negative. That's what it means for a function to be even. So even function, things like parabolas, it means it's symmetric about the y-axis. And then mathematically, and this is the one that you'll see a lot more often, mathematically it means you plug in a negative x and you get the same thing as a positive x. So let's do an algebra manipulation for something to do with an even function. So let's go ahead and do that. Let me get to the next page here, right? So the question would be, let's call this an example, and the question would be, determine if it is an even function. And I'm going to give you the function. Let's say f of x is equal to x to the power 4 plus 3x squared minus 7. Okay? Now, I could graph that, and you could plug it into your graphing calculator. Maybe that would make it easier, but it's going to be kind of a pain. So what I want to do is I want to figure out how to do this algebraically, and that means not graphing it, just using the algebraic manipulation. So what we're going to do is we're going to go back and actually use that algebraic, the mathematical definition for an even function, and that is plug in negative x. So I'm going to actually very literally plug in negative x. I'm not going to choose a number, I'm going to leave it calling x. So everywhere I see an x in my function, I'm going to replace it with negative x. So this will become negative x to the power of 4 plus 3 and then negative x to the power of 2 minus 7. And you'll notice everything else stayed the same. It's just all of those x's got replaced with a negative value. And then we have to simplify. So my next line down, I'll go ahead and simplify. Now let me think about this for just a second. Let me maybe highlight this for you. A negative number to the power of 4. So that's 4 negatives. That's going to go right back into a positive, right? And that's the beauty of those negatives. So that'll go right back into a positive. So this will become now a positive x to the power of 4. And then I still have that plus 3. I can't change it. And then the same thing for this one. A negative number to the power of 2. So a negative number to the power of 2 will also turn back into a positive. So now that's just a positive x squared. And then a minus 7 is a minus 7. You can't change anything there. Now, what your job is to notice is you'll notice what I ended up with is exactly the same as what I started with, right? So that is the idea of an even function. So because this equals the same thing as what I started with, it is even. Now, if it didn't equal the same thing it started with, then it wouldn't be even. Okay, so ta-da! So that's how we know that it is even. Okay, so now we got to go ahead and talk about same concept, but now we're going to deal with odd. So let's talk about odd functions now. So for odd functions, again, what I'm going to first do is I'm going to do the visual. So let's do a visual. Let me do this. Will be my x. This will be my y. I'll give you kind of a little bit simple visual, and that is going to be the x cubed graph. Now I'll draw my arrow. So let's call this f of x equals x cubed. Now, what is it that makes this odd? So why is this an odd function? And one of the things is, now you couldn't fold this in half. If you folded this in half, it wouldn't be the same picture, right? It's not a butterfly. But if you were to take this graph that I've drawn and you were to pick up that piece of paper and flip it completely upside down, it would be the exact same picture. So that is a rotation all the way around, a completely upside down picture. And that is what is called symmetric about the origin, meaning if I were to leave the origin the same and just flip my picture upside down, I would end up with the same picture, and that's what it means to be an odd function. Another way of saying that, the mathematical notation for that, would be if you were to plug in your negative number, you would get negative of the original, right? So if I plugged in positive 2, I got positive 8. But if I plugged in negative 2, I ended up with negative 8, and that's what we mean by that. So those are ideas. That's the definition and all the different examples for odd functions. So let's go through and do the same idea for an example. How do you figure out algebraically without having to graph it if your function is odd or if it's symmetric about the origin? So let's do another example here. Okay, so this example would be now determine if this is an even or an odd function. So maybe it's one or the other. We now know a little bit about both. Let me give you the function. Let's say f of x excuse me, is, let's say x to the 5th minus 4x cubed plus 12x. Simple enough? Okay. Let's give it a shot. So how do we know? Again, I really don't want to graph that. You could if you wanted to. We don't got that kind of time. Let's do this algebraically. So what I mean by algebraically is you plug in negative x and see what happens. You do the same first step, determining if it's even or odd. This is the same first step. You still plug in negative x, and your job is to figure out what simplifies. So all of those x's are going to get replaced with a negative x. So notice how I always put them in parentheses. It's a really good habit that you should get into. Otherwise, it's really easy to accidentally subtract things when you should have multiplied and so on. So get used to plugging those in with parentheses. So all of these x's from my function got turned into parentheses right below it with a negative x in it. And then you simplify, right? So that's what we're doing here. Is we're always simplifying, see if we can make our lives a little bit easier. It's a big part of mathematics, simplify. Now I have a negative number to the power of 5. So that's 5 negatives. Now 5 negatives will stay a negative, so that'll become negative x to the 5th, if you guys can see that. And now the same idea for the next one. I'll stop highlighting here for you, but hopefully you guys can hear me talking through. This is now a negative to the power of 3. Well, maybe this one I will highlight. This is a little bit tricky one. Okay. Negative to the power of 3. Now that's a negative, right? 3 negatives gives me a negative. But I also have another negative out there. So that's a total of 4 negatives, which then will turn into a positive 4x cubed. Can you guys see how all of those negatives canceled out? And then you'll do the same thing for the next one. 12 times negative x. Now that's only one negative, so it's going to stay a negative 12x. And then you ask yourself the question, does this equal the same as the original? Does this equal this? No, it doesn't. It certainly does not equal that, right? Those are not the same. So what you do next is you actually have to figure out, let me go back and erase that. Because those aren't equal, we're going to actually try to factor out a negative. And let me explain to you why in a minute, but just bear with me now. Let's factor out the negative. And then this will become now a positive x to the 5th, a negative 4x cubed, and then a positive 12x. Now that I factored out the negative, is what's left over the same as that? Yeah, it is. So this is now exactly, I ran out of space, sorry. Now this is the same thing as when I factored out the negative, it's the same as the original. So that goes back to the fact on the previous page when we just talked about that before. When you plugged in the negative, you get negative of the original. That's exactly what we have. So this is an odd function, not even. Alright, okay, so there's your even and odd right there. So a couple of other things that I think are worthwhile. And by the way, if neither of those worked, then of course it would be neither even nor odd. So not every function falls under an even or odd category. Some functions are neither even nor odd, so that's still a possibility. Let's maybe do an example of that really quick. So one more example, again, determine if it's even, odd, or neither, so that way you guys can see what's going to happen. So let's do f of x equals negative 2x cubed plus 4x minus 8. Okay. Alright, so again, determining if it's even or odd, it's always the same first step. Your first step is always to plug in negative x. So all of those x's get replaced with parentheses and then the negative x instead of just an x. Everything else stayed the same. Notice everything else just copied down right below it. And then we simplify, no different than what we did in the last two examples. We simplify. This is a negative to the power of 3, so it's 3 negatives with another negative. So that's a total of 4 negatives. So now I have 4 negatives, which turns into a positive. So this is now just a positive 2x cubed. And then you continue on for the rest of it. 1 positive and 1 negative gives me a negative 4x. A negative 8 is just a negative 8. Okay. And then you ask yourself the question, right? Is this the same as the original? If it was, it would be even. But it's not. So it's not even. Okay? So if it's not even, the next thing that we try to do then is we try to factor out a negative. So you factor out a negative, and that changes all the signs of all of your terms in your function. So this will now be a negative 2x cubed, a positive 4x, and then a positive 8. And then you ask yourself the question, is that, once I've factored out the negative, the same as the original? Again, it's not quite. You see how that positive 8 here and a negative 8 here? So it still didn't work, right? So because neither of them worked, because neither even nor odd, neither of them matched with the original, this is in fact neither even nor odd. Ta-da! Okay, so that's the examples for even and odd functions.